A 8 kilogram box that accelerates horizontally from a 18 Newton force to the right and a 30 Newton applied force at 40 degrees above the horizontal, and our friction coefficient is 0.2. And the question is asking us to find the acceleration. So let's draw a free body diagram. Here's our free body diagram with a 8 kilogram box with obviously our mg, our gravitational force, our normal force, our friction force that is going opposing our motion because our motion is going this way, so our friction must be going this way. We have our 18 Newton force to the right, which has no angle, and we have our applied force at 40 degrees. So we have to break this force into its vertical component and its horizontal component. So its vertical component, this is going to be Fy. This is going to be F sine theta, and this is going to be the horizontal component, which is going to be F cos theta. And the reason we have to break the components down into its vertical and horizontal is because, just like with the projectiles, it's not directly straight up or straight down, but it's not also directly left or right. It's in between, so that's why you have to break it down. So let's start getting some values. 30 times sine 40, that's our Fy, is going to equal 19.28, and 30 times cos 40, that's our horizontal angle, is going to equal 22.98. So let's solve for our normal force now. So our normal force equation is going to be mg minus Fy. Normal force we don't know. Mg is going to be 8 times 9.8 minus Fy value, which we just got here, is 19.28. We're going to get a normal force value of 59.12. So now let's solve for friction. The equation for friction is the friction coefficient times the normal force. So that's going to equal 0.2, that's our coefficient, times our normal force, so which we just got is 59.12. Which means our force of friction, is 11.82. Finally now, let's find the horizontal acceleration. So we know that the sum of all x forces is still going to equal ma. What horizontal forces do we have? We have our Fx, which is 22.98, our applied force, which is 18, and we have our friction, but this has to be negative, so it's 11.82. Equals m, that's just 8, and acceleration value. We're going to get 29.16 equals 8a. All you have to do is just divide 8 by both sides, and we are going to get 3.6 meters a second as our acceleration value. So yeah, for this problem, a box that has 18 newtons applied force, a coefficient of 0.2 for friction, and another force at 30 newtons applied at 40 degrees above the horizontal is going to accelerate 3.6 meters a second, and that's our answer. Alright, next problem. By the way, shout out to my friends Adam and Matthew. So Adam and Matthew are playing a game of tug of war. Adam applies a 35 newton force to the right at 30 degrees, while Matthew applies a 28 newton force to the left. And the box has a mass of 6 kilograms, and the friction coefficient is 0.25. The question is, who wins? Now, winning is defined as, in this situation, who has the greater net horizontal force. So here's our free body diagram with our normal force, or mg force, and we have Matthew pulling here at, this is going to be negative 28 newtons because it is to the left, and Adam here with 35 newtons to the right, which is going to be positive. So let's break these forces down. Obviously here is going to be Fy, which is going to be F sine theta, and our horizontal component, which is going to be Fx, which is F cos theta, and same thing for Matthew's side. So let's get each person's vertical value and horizontal value first. So 28 sine 20 is going to be 9.58, and 28 cos 20 is going to be 26.31. And for Adam, 35 times sine 30 is going to be 17.5, and his horizontal value is going to be 30.31. Since these two are both pulling on the box at the same time, they're going to be sharing a normal force value and a mg value. So let's just find the mg value first. which is going to be 6 times 9.8. It's going to be 58.8. Also sharing a normal force value, which is going to be mg minus Fy of, which is called as Fy Matthew, and Fy Adam. The normal force here is going to equal 58.8 minus Fy of Matthew, which is going to be 9.58, plus Fy of Adam, which is going to be 17.5. So this is going to be 31.72. Now that you have the normal force, let's find the force of friction, which is going to be the same thing, just the friction coefficient times the normal force. So the friction coefficient is going to be 0.25, and the normal force, which is shared between these two, is 31.72, which means our friction force is 7.93. To find who actually wins this game, it's whether the net horizontal force is going to be negative or positive. If it's negative, Matthew wins. If it's positive, then Adam wins. So let's get our final values and tally them up. So we have Adam's force, which is 30.31, that's positive. We have Matthew's force, which is negative, which is 26.31. And we have the friction, which is minus 7.93, which means the net horizontal force is negative 3.93. And yes, this is negative, which means Matthew here would win the game. And that's our answer. Thank you for watching.